And when I'm going to do that. No yawning. Let's see. Somebody tell me what chapter logarithms are. We just came out of chapter 4, didn't we? Chapter 3, so it's chapter 4. It should be chapter 4. Make sure. Start off with exponentials. Yeah, rational functions. Should be logarithms. Alright, chapter 5. I don't think we cover a lot of these. We don't cover, it's just graphing and calculator, but then we jump from chapter 4 to chapter 5. But let me look it up right quick. I better check. Of course, I have to go to Blackboard to check, and then I have to go to a separate section because he separated it from the. Some of the things these people do. And then you have to log in to Blackboard separately. It's up. Is it running today? I think it's been down, hasn't it?
It's been partially done. When I click the notification, it doesn't come off, but if I go to the course, it works.
My notifications won't go away. I check it and they just stay up there.
That's why.
I go to check them and it just sits there and loads.
That's why people don't like Blackboard.
I've had 3 things graded and I go.
Well, I don't understand why the link is still messed up into my lab's class.
Yeah, it's still like regraded.
I don't know about that. This is the first semester I've seen it. Like I said, I told y'all, I've never seen it like this. I think they must have got it. Yeah. All right. We just finished this. So that means that we're in this. So we'll do a little bit of this. Yeah, we'll have a test on this, and then we'll go to this. And then all that's left is, we'll hardly ever get to that. You don't need it for trig, so actually you don't need logarithms for trig, but you need it for calculus. So we'll do chapter 4. Have you a little test on it, give you a little bit of points, and then we'll do logarithms. So 4.1, 4.2, and 4.3. 4.1, 4.2, and 4.3. All right, I've already given you the family graphs of 1 over x and 1 over x squared. Half a volcano and a volcano, remember? So make sure you can pull them up in your family of graphs. Got a good place, right on the front page. You need to laminate that. Laminate it? Golly, that would take extra work. Yeah, you don't want to do that. So there's the 1 over x. You've already got that in your family of graphs. The half a volcano. And then, well, most of these you do on your calculator. I'm not going to hold you to. What is that x plus 1? What does that plus 1 mean? Horizontal shift of 1 to the what? Left. So it's, instead of the origin being here, it's right here, 1 to the left. The 2 means what? The 2 can be put on the outside, which means that it's going to be compressed. It's going to be skinnier than the original. So that's how you do those. I'm not going to worry too much. There's your volcano. And of course, if you move it, same way. -1, what does -1 mean? That means 1 to the right. So instead of it crossing here, it's going to be 1 to the right. Again, I'm not going to worry about those. You should be able to do that. That's 2 to the what? Two to the what? Left. Positive 2. Y'all can't see.
It looks like it's a division symbol.
Oh, whatever. When have we started dividing by 2 in the denominator? Gosh. All right. So I'm not going to spend a lot of time on this. 4.1, I'm not going to spend a lot of time on. Okay. This is where you get into vertical asymptotes. So write those down. You got to learn how to spell it. It's asympt and then tote, like tote in a bag. Tote. So write those down. Vertical and horizontal asymptotes is basically the line that you converge on, but you never do what? You never do touch. Convergence. This is when you start getting into limits. You're going to get into limits your first week of calculus. And by the time y'all take my trig next semester, y'all will be taking my calculus probably in the fall or the summer, depending on when we offer it. So y'all need to sign up for that trig course so I can get some students in there. And if you're not going to sign up for it, because then you're going to fail this course if you don't sign up for it. Did y'all talk to your advisors? Okay, wait till December. Just wait.
Well, when do you offer that trig class? That was like 12 or something on the class.
What?
I was looking at the time. You don't do any afternoon classes, do you?
I do, yeah. I mean, I'm here till 3 o'clock in the afternoon every day, but I don't do the evening.
Yeah.
I thought I showed y'all my classes. Did I not? Okay. I don't know what time the trig is, but y'all need to sign up for it. Yeah, something like that. And if you need a second college transfer course, that's a good one to take since it's right after this one. But the vertical asymptotes, right there, you can't tell much there. You can tell more when you do an actual example. Setting the denominator equal to 0. Write that down to find the vertical asymptote. Setting denominator equal to 0, because these are all rational functions. So you're going to set the denominator equal to 0. And that's what number 1 says right here. Find by determining, it's right there, vertical asymptotes. Find by determining the value of what makes the denominator but not the numerator equal to 0. Now there's a test for horizontal asymptotes. We'll get to that later on in the class, or later on in this section. And there's a prime example of denominator equal to 0. They use the reverse FOIL method, and that's fine. You can do that. You can also use what? Complete the square and just forget about the vertex. Just go straight to solving. So you can do complete the square, or you can do reverse FOIL. And what I mean by going straight to the solving? Well, if you take the 2x blah blah blah, then that's going to be 2x squared plus 5x minus 3 is equal to 0. 2x squared plus 5x plus blank is equal to 3 plus blank. X squared plus 5 halves x plus blank is equal to 3 plus 2 times blank. The 10 was right. 5 halves divided by 2 is what? 5 fourths. 5 fourths squared is 25 sixteenths. And that's going to be 2 times x plus 5 fourths. 1 squared is equal to 3 plus, I don't even know what that is. Is that 25 sixteenths over 50 sixteenths? And then here, and this would be 48/16. 48 plus 50 is 98/16. So 2 times x plus 5/4 quantity squared is equal to 98 over 16 divided by 2, multiply by 1/2, and x plus 5/4 quantity squared is equal to 98 over 32, and then you can finish it out by taking the square root, adding and subtracting. Now the reason I showed you that is right in here we would stop and do the vertex and all that. Well, you don't have to do that, you just go straight through if you wanted to do that instead of the reverse FOYL. You'll come out with the same answer. Okay? But in this case, the reverse FOYL is a whole lot what? Quicker.
Let me ask you this. This is just off to the side. When you reduce that, you get 49 over 16, which is which both the square root can be taken out. You know.
Where's 49 over 16?
When you reduce 98 over 32.
Yeah.
So all the problems we do, none of them reduce that. You always end up with a radical. You know,
Sometimes, yeah, sometimes they reduce that.
So like that one there, you would have 7 over 4.
Yeah, and then you can take the square
plus
root.
the 5. Okay.
Yep.
None of those you actually get an answer on.
I
You know
know.
what I mean? That one you actually just get
Yep.
it right.
So that's the way you find your vertical asymptote. So at 1/2, x is equal to 1/2, you got a vertical asymptote, which means you got a dotted line that goes like this. And then at -3, you got the vertical asymptote. Like that. So your function can go like this, and like this, and like this, but not touching those 3, because what happens if you use 1/2 or -3 in this function? What happens? You get 0 where? In the denominator, which will cause you an error, mathematical error. You can't divide by 0. When I was in a abstract algebra course at Clemson, the teacher told us to explain dividing by 0 and why is it undefined. And of course these math geeks, I call them math geeks because I'm not a math geek, they go through and write 3 or 4 pages, and I said 2 rooms are built with no windows, no blah blah blah, no windows, no doors, blah blah blah. The only thing that's in the room when it's built is a table with $500 $1 bills on the table, and one table with $500 bills on $500 $1 bills on the table, and in one room you have 3 people. In the other room you have no people, and you build this room and you put a top on it, and those people are in that room. In one room you divide the money by the people. In the other room you divide the money by the people. What's the outcome? Well, in the first room you have $500. I think it was $300. When you divide it by 3 people, it's $100 a piece. In the second room, what happens to the money? It sits there forever. Why? Because there's no one there to. And the funny thing was, my explanation of dividing by 0 was about 3/4 of the page is handwritten. Theirs was like 5 or 6 pages, and you couldn't understand a word of it. And my teacher was kind of a smart alecky teacher, and he said, I'm going to read this. So he read mine, and thinking it was going to embarrass me, and the whole class went, oh wow, I never thought about it like that. And it backfired on him. Anyway, they loved it. The class loved the explanation, and the teacher was making fun of me, but the teacher went, what are y'all talking about? It doesn't make sense. And they said, yeah, it does make sense. So it kind of backfired on the teacher. But anyway, you can't divide by 0 because if there's nobody there to divide the money, it just what? It just sits there until, until somebody opens up the room and gets the money out or whatever. It just sits there because you can't divide by 0. And I just thought about that when I was putting that 0 there. Anyway.
So any function that's got, it's a fraction like that, that's when the asymptote comes into play.
Yes. Asymptotes are only when you got a fraction. Remember, domain? Domain is only affected by a radical or a rational. Okay? Capiche? No, you don't. You're going to fail.
It's nothing 150 homework problem you can't straighten out.
Nope, you're right. That's true. What? Yeah, let's do 200. All right, in this case, this is simple. Where's the vertical asymptote? At 3. Well, how do you find the horizontal asymptote? There's a horizontal asymptote. How do you find it? Well, I'm going to get to that right quick. As soon as I find the page of the song. There it is. And you need to write this. You don't have to write it down word for word because all of it's BS. But to find the vertical asymptote, you set the denominator equal to what? 0. That's what you put for that. Now, here's how you find the horizontal asymptote. Go ahead and read those, and I want you to ad-lib them in your notes. Read them on the board, and then I want you to rewrite it in your notes the way you can understand it. If the numerator has a lesser degree than the denominator, then the horizontal asymptote is 0. Then y is equal to 0. If the numerator and the denominator have the same degree, and the function is in the form blah, 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 then dividing by x in the numerator and the denominator produces the asymptote. Y is equal to basically the coefficient over the coefficient. And the last one is the numerator and denominator. Read it. And then I want you to put those in your notes in words that you can understand. Yeah, I'm sorry, I forget. Y'all sit at the back of the room.
Hey, you're making the assumption that me reading it's going to help me understand.
No, I want you to write it in your words, and then I'll explain it. You ain't got to write a whole paragraph right here for C. All you got to say is numerator of the degree higher than the degree of the denominator, then use long division. That's basically what that says.
I was hoping that long division would go away.
No, this is going to go away about like the shortcuts are going to go away. They're never going to go away. Complete the square, never it's going to go away. Logarithms could go away for a while, but they're going to come back. Now you know why people that build bridges don't just take 2 math classes. Always got to be thinking about this stuff. Always. Okay, the degree of the numerator. What does that mean?
The power was raised to.
Yes, the power that's raised to. So if you have, if the degree of the numerator is less than the degree of the denominator, x to the first plus 2x over x squared plus 3x plus 4. Now I have to show you all this because this degree right here is more than that degree. Then what does that mean? That means you basically have a horizontal asymptote with what? Horizontal asymptote with 0. I think that's what it means.
Mm-hmm.
I think that up here it is. So that's what you do. You look at the degree of the numerator and the degree of the denominator. The reason I'm showing you this like this is because I had an algebra teacher that just assumed that we knew this, and they didn't even go over it. So you look at the degree of the numerator and the denominator. So what if the numerator and denominator are the same? Well, then you'd have x squared, let's go with x squared plus 2x minus 3 over 2x squared plus 3x minus 2. And you see that this guy is equal to this guy. What do? Quit? No. You take the coefficient. So the horizontal asymptote is equal to what? So see, you need to rewrite this and rewrite this and then use this as an example so you understand it. And then, of course, the third one. And that's the one you quit on. Well, I finally decided how to make the eraser bigger.
I think it's because it's in
That's it. That's how I know. You make the eraser bigger.
there. I understand that.
Yeah, now I know how to do it. Just got to make the board 3 times bigger. So, what if you have this? X squared plus 4x plus 3 over x minus 2. So here's the degree of the denominator is what? It's smaller than the degree of the denominator. So this one, you use long division. and either it's going to come out as an oblique. Yeah, it's going to come out as an oblique. Divide, there it is, divide the numerator by the denominator. And disregard the remainder. And oblique, if I spelled it right, asymptote. If I spelled that right. Today is challenging day in Hubert's class. And I can't even write that. So oblique asymptote. Crazy. So that would be x minus 2 into x squared plus 4x plus 3. Are all place values there? Yes. How many times will x go into x squared? X times x is x squared. X times negative 2 is what? Negative 2x. You always what? Subtract, so that turns this into a negative and that into a positive, taking that first column out. So 4 minus 2 is what? 2x. Ooh, I'm writing right-handed. And bring down 3, help out. What? Oh, I already did. That'd be 6x. Thank you. Sorry. And then how many times will x go into 6x? 6x. And then 6 times negative 2 is negative 12. You always subtract and make that a plus. 15 is the remainder. You don't care about 15. And there is your oblique asymptote. An oblique asymptote means the line is going to be going like this. It's going to be a line. It's going to be a slant.
You said more than a meter?
Mm-hmm. They're not asking you how many times something can go into something. They're asking you what is the asymptote. So those are your 3 types of asymptotes, horizontal asymptotes. One is going to be 0. The other is going to be a coefficient. And the third is going to be oblique. What does it look like? Well, I'll show you. If they got one down here. Probably this one. Nope. Nope. They're giving you examples of the 3 asymptotes. Hold on, I'm getting to the last one. There it is. See that dashed line right here? Those of you listening, see that dashed line right here? That's an oblique asymptote. Hold on. Y'all finished? Because y'all being rude, y'all talking while I'm talking. That's an oblique asymptote. Now your calculator's not going to show it unless you put it in there. And the way that you put it in there is when you divide, you get x plus 2. You graph this, and then you graph the vertical asymptote. Mm-hmm.
And it goes through the
Goes right here.
okay.
You just have to blow it up a little bit. Right there. You know that the vertical asymptote is x minus 2, so you can't use 2. So that's why you got to put the dashed line around that way. And then you do the, okay, well the degree of the denominator is less than the degree of the numerator, so I need to divide. And when you divide, you come up with x plus 2. And you don't have to use long division. You can use shortcut number. No, you can't do that. No, there'd be a remainder. There's a remainder. But anyway, it's x plus 2, and there's x plus 2 going right there. Now, you will use the calculator a good bit in these 2 sections, but you also will use some algebra. How will I do that? on the test, I might get you to find the vertical asymptote and just give you an algebraic equation, and then I might tell you to graph the function, and I'll let you depend on the calculator for that. So in this two or three sections, you're talking about half and half. So this should be an easy test for you. Unless you don't know how to do any of what I've showed you, which you do. You know how to do long division, you should. Okay. Behavior, here's our behavior. If n is even, you got a parabola. If n is equal to 1, you've got something like that. And then of course odd, you've got the S looking shape curve. So, but that's why I don't want you to have to learn that. Just use a calculator like that. But this one is x squared. So x squared, if n is even, that means you're going to have some kind of parabola look to it. But that's why you use the calculator. All right. This question, look at this one. This one is one that's real easy. You don't even have to divide it. Why?
Because the numerator is exactly 1.
No, that means you have to use long division, but you don't have to use long division on this one. Why? Because the top is shortcut number 3. So you can use factoring instead of long division. Remember, the factoring is not going to go anywhere. It's going to be a nightmare for you until you decide to what? Learn it. Well, you can quit too.
You see everybody's mind.
X plus 2, x minus 2, divided by x minus 2. And then what? So your function is really x plus 2, but it's going to have a bubble at 2. Why? Because in the original equation, if you plug the 2 right here, what would you get?
0.
So you're going to have a bubble at 2. And you need to highlight that. So draw your function, x plus 2. 1, 2. And then what happens at 2? 2, there's going to be a bubble. Now, the way that they do that in a calculator, and it depends on how new your calculator is. Take your calculators out. And let's see what they do, because I have no idea what the new ones will do. They probably will put a bubble there. But the old ones, I don't know. Graph y is equal to, what was that function? Somebody tell me what that function was.
X squared minus 4.
X squared minus 4 divided by what?
X minus 2.
Divided by, parentheses, x minus 2. Because if you don't, the calculator might think you're taking 4 and dividing by x minus 2. That's just something I do because I want to make sure the calculator don't misunderstand. You can put parentheses up top too. It doesn't matter.
I use parentheses a lot.
You can do that. That's fine.
X squared minus 4 divided by
X minus 2. I think that was the original problem, right? Second, insert, and I'll put parentheses in the top too. That's just a kind of a, what is it when you just want to make sure? Make sure. Divided by. Because if you don't make sure, then guess when it's going to bite you in the rear? Whenever you don't make sure. And graph. And Okay. Did y'all's work?
It did, well, I didn't like the parentheses.
Yeah.
Yeah, as soon as we say that.
That
When
shouldn't
I
have
took the
anything to do
parentheses
with it.
out of the denominator.
That shouldn't have anything to do with it. There it is. Now, the older calculator, some of y'all with a newer calculator, tell me what it looks like.
Yours is not showing.
Huh?
It's over there.
You got an awesome keyboard.
Thank you. See?
That's correct.
Yeah.
Okay.
So look at your x is equal to 2 right here. What does your calculator show? I hope your new calculator shows something a little bit better. Let me see what zoom fit is 0. I thought I hit that, but I want it, so I'm gonna blow it up. So zoom box.
You got parentheses on the top and bottom. You know, when I took the parentheses off the bottom, it gave me one thing. When I took them off the top, it gave me another. I got 3 different things. Just with parentheses.
I'm sorry.
I think
That's why you're gonna
I
fail.
think yours is like this.
There we go. See, at 2, mine doesn't show it. Does anybody's got a new calculator that shows a bubble? Nobody? Well, there's only 3 people in here with a calculator. Okay. That's good. That's a good thing. I'm very happy with that. It'd be fine with me if none of you show up with one. That way I know people are out there that can make change. But how do you catch? You go to table. Where's table? Second. Thank you. That's how much I use a calculator. And go to 2. Ooh, fix this. Second table set. Hang on, 1. Woo. Second. Okay, it didn't do 1. Oh, table start 0. Table 1. Second. There we go. You actually have to find what? The error. And that error, just put out to the side, is bubble. That means that there's a bubble there. Because you can simplify it and graph the function, but you can't ignore that there is a number that will F it up. Okay? Or mess it up. And that number is what? 2. Very important that you realize that. Or you could just ignore it. Just ignore it. It
Is
doesn't
that
matter.
something that you would like algebraically check every equation?
Yeah.
Just
This
plug
guy,
a 0 in?
if it, yeah. And you're going to learn that with solving systems of equations too in the last unit. If you find what x is, the first thing you do is plug it what? Back into the original to see if it makes sense. You always do that. Remember in pre-algebra, you used to do it to see if you got the right answer.
Yeah.
All right. But in solving systems of equations as well as rational equations, if you say, you solve and blah, 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 and you get x is equal to 2, and you put x is equal to 2 down for your answer, then I can mark it wrong. Why? Because x cannot equal 2, because x will give you 2 will give you a what? A no solution. So you can't put x is equal to 2 as the answer. And that's what students usually do. Okay? So always go back and check. When you're dealing with a radical or rational, you have to make sure your answer makes sense, because the answer could give you an undefined function. Okay? So that's a good example. So now we got 3 types of problems. You got a vertical asymptote, you got a horizontal asymptote, and then you got problems that you can do by reverse FOIL and cancel. You can still draw it. It doesn't have a vertical asymptote, but it has a what? A bubble. A bubble is the same thing as a vertical asymptote, but a linear function does not converge. A linear function goes whoop, whoop. A nonlinear converges. And that's the difference between the two. Nonlinear has vertical asymptotes. A linear has a bubble. Capiche? Capiche. You think so? Okay, well then let me do some more to confuse you some more. Let's see. Okay, these are just you do with graphing calculator. That you do with graphing calculator, that you would do with a graphing calculator. But can you now why is this one, why do you not have any vertical asymptotes with this one? There's one simple explanation. Just look at it. You don't have to do anything, just look at it. You should have answered it by now.
I have no idea.
Look at the denominator. Should be answered it by now. Why? Why would that have anything to do with it? Huh? No. In fact, you don't mess up this one. Why? You're getting there. You're getting there. What can you not have in the denominator? Okay. Build on that. Build. Okay. You don't have no clue what you're doing now. You're getting cold. You were getting warm, and then I tried to get Mr. Ellis to help you out, and of course, he didn't help you out. He hung you out to dry.
I ran.
Yeah. Push you under the bus, then run. Okay. You said because. No.
Is it because you can have two solutions? You got something to do with that?
No, be quiet.
We got no idea. Teach us, teach.
No, I'm trying to get you to think. All right, now, you said because the denominator was doing something, and then I said, what can you not have in the denominator? And you said 0. Now keep looking at the denominator. Eventually somebody's going to figure it out. What can you not have in the denominator? Hmm?
Oh, you squaring it. It can't be negative.
What? It can't be negative. Why can this not be negative? Or why can I not get 0? You can't get 0. Okay?
Oh, because you're going to add 1 to it no matter what?
What does a square give you?
A positive.
Okay, what's a positive plus 1?
Positive.
So you can't get what?
0.
That's why there's no vertical asymptote. I thought y'all would have got that like 5 minutes ago.
It's just because you're adding 1 to it, right?
Well, no, the square is always going to give you a positive number. A positive number plus 1 is always going to be a what?
Positive.
It's kind of like infinity and beyond, okay? If you have a positive number and you add a 1 to it, what are you always going to get? A positive number.
But that's all.
Okay, let's go back. Y'all not getting it. Okay, a negative means negative, right? And a positive means positive, right? So if I add 1 to a positive number, I'm always going to get a what?
Positive.
So can I get 0 with a square and a 1?
Negative.
Thank you. Some of y'all are still saying, what the hell is he talking about? You just keep looking at it.
But you could with a cube.
Tell me the number that will give you 0 in the denominator. There is none. Well, what about negative 1? Well, negative 1 squared is what? 1 plus 1 is a positive number. Some of y'all are still not getting it. But anyway, anytime you have x squared plus 1 or x squared plus 2 or x squared minus 3 or x squared plus 4 or x to the 4th plus 1, x to the 4th plus 2, anytime you have a square plus a positive number, you're not going to get a 0. What? What did he say?
Yeah, because if it were a negative, you couldn't get a 0.
Yeah. Y'all getting it? Good.
Hey, it just takes a while.
That's like football. Yeah. So that's that. And that's 4.2. Now 4.3, we'll just go ahead and throw 4.3 in there to really confuse you. And that is, should be equations, which is real easy.
Hey, if that's your goal, you're good.
Good. Oh, this is supposed to be your easy section.
Wait, so what was tested?
Tomorrow. Wait, what? The x squared plus 1 is what? All right, the first two are all about finding your vertical and your horizontal asymptotes, finding your oblique asymptotes, no asymptotes, or a bubble. Okay? That's what all of those first two units are. The last unit is real simple, solving equations, not systems of equations. Now, I've been teaching y'all since the beginning that if you're given a fraction, what should you try to do to work with a fraction? You try to get what? Get rid of it. And that's what you're going to do here. You're going to multiply by the denominator on both sides. So, in this case, you've got x plus 2 over 2x plus 1 equals 1. So copy that right quick. I would pull it. Copy it so I can write it down on the whiteboard. I'm not going to snip it because I don't feel like doing it right now. Monday gets me lazy on Wednesday.
So at this point, I just use 0. Right? That's not part of it.
Yeah, just go ahead, just 0 it out. All right, so let's take that problem. How does my mama tell me when I'm going to have to do that?
She might have an apple pie or something.
Yeah. F of x, or what does it say? I'm sorry. It says x over what?
X plus 2 over 2x plus 1.
Over 2x plus 1 is equal to what?
1.
All right, multiply both sides by 2x plus 1. That's the denominator. So multiply both sides by 2x plus 1.
What, that?
It's 1.
Yeah. The denominator
You
is
got a negative 1/3 of the third side. How did you get that?
She's not here every day, so I can't know. I mean, a lot of this, it's like I get it, but we just heard about it, you know? I'm gonna have to ground it out on the homework to do it. Isn't that class, didn't they do? Yeah, that's so stupid. Sometimes we classes at East Tennessee State or not, there's the whole week. I was watching this video last night. It's like, have a good week next week. It's like, huh? Yeah, my plan was to take all I could here and then transfer, but then as the more I got into it, I realized it would be better to do it at the same time. Yeah, I'm at 85 on the set. Notice I took the first one in there, 97. And I did a screenshot and find my notes and put it out. You know what I mean? After you finish, you look over all the ones you know, so you got answer. Yeah, and it's not the same number, but some of them like with the stupid brackets. And
I had the same question twice in the same class.
I did too last night. I had one question and then I had a dumb question for the bonus one, and then the very next one the same thing.
Yeah.
And you know, some of them that like already has the parentheses for your answer. And then some of them that I missed one because it didn't have it, but I thought it already did.
All right, multiply both sides by 2x plus 1. And that cancels. X plus 2 is equal to 2x plus 1. And this is the smallest bucket, so it comes across. And 2 is equal to x plus 1. Take the x over, minus 1, x is equal to 1. Now, you found the solution, but what do you have to check? You have to check to make sure that the solution will give you an honest answer. So take the 1, plug it into the denominator. 2 times 1 is 4, or 2 times 2 is 4. 2 times 1 is 2, plus 1 is 3, and that's okay. So your answer is 1.
And that is the
Solution.
asymptote.
No, that's the solution.
So that's the.
In other words, if you plug 1 into that, you're going to get 1. Or, I'm sorry. If you plug 1 into this, and 1 into, well, you don't.
Yeah, it is.
It'll equal 1.
Yes, 3.
Yep.
That's the x-intercept in that equation?
No, that's the solution. That's the solution. You got an equation, you need a solution. You want to find out what x is. This is just like an algebraic equation. So let's do another one. Because this is going to make up 80% of your test. The equation part. Because you're going to see these just like complete the square and just like shortcuts. There's another one. So I'll cut this one out. All right. Now, what is the common denominator of x minus 2 and x plus 2?
X minus 2, x plus 2.
Which is?
X squared by 4.
How'd you know that?
That was a lucky guess. 0.
Yeah, let's screw it up. So, I'm going to multiply through. Well, I'm going to rewrite it. I'm going to rewrite it to show you x minus 2 plus 1 over x plus 2 is equal to 8 over x plus 2 times x minus 2. Because that's basically what we've got. So the common denominator is this guy. So I'm going to multiply through by that guy. And I'm going to put a baby step in here for y'all because some of y'all might need a baby step. I'm going to mention your names. But x plus 2 times x minus 2 over 1. X plus 2 times x minus 2 over 1. X plus 2 times x minus 2 over 1. And then put the rest of it in there. X over x minus 2. 1 over x plus 2. And 8 over x plus 2 times x minus 2. Now what happens here? The x minus 2's cancel. You're left with x times that. X plus 2's cancel. You're left with 1 times that. And that's left with 8. So x times x plus 2 plus 1 times x minus 2 is equal to 8. Now, I don't know about y'all, but I'd much rather work with this than work with this. Finish it out. If you can't, then consider yourself a failure. X times X plus 2X plus X minus 2 is equal to 8. X squared plus 3X is equal to 8. And you can bring the 8 over, it's going to be minus 10. X squared plus 3X plus minus 10. Is it minus 10? Is equal to 0. I'm running out of room and I can't even read my own writing. So dang old 2 and 5, dang old X, 2, X, 5. And what sign is this? Positive, so that means the 5 has to be positive. What sign is like or unlike? Unlike, so that has to be negative. So positive 2 and what? That's our possible solutions. So we go up to our handy-dandy equation and we plug in 2. 2 minus 2, bang. So 2 is out. So your solution is what? Negative 5. Why is the 2 x'd out? Because 2 will give you an unknown term in the first and the last term. In the x minus 2 and x squared minus 4, it'll give you a 0. 80% of your test is going to be made up of these, so you better get good at them. We'll spend Monday going over another 5,000 or 6,000 of them.
So you know, I get hung up on the simple math. I got the exact opposite. Yeah. I factored it as a 5.
That's because you reversed.
And a negative.
You reversed 4 wrong.
What did I do?
You got to have x plus 5 and x minus 2.
Okay.
Because that has to be positive. Your biggest number has to be positive.
Oh, never mind. I didn't solve for it. I'm just looking at my factor. Yeah, I just stopped right there.
You should have just quit. You shouldn't have even tried it.
0.
That's funny. Now, in calculus 2, I used to have a calculus 2 class. It was very fun. And I mean, they had personality and sense of humor. They wanted to tit on a bull. And they were very funny. And this one guy, he said, you know, I've done all this homework and every single one of these problems come out to be 4. So I'm just going to answer all the questions from now on to be 4. And after he said that, just about every single problem we did in class came out to be 4.
Really?
It was really weird. And to this day, he Facebooks me every while. I'll put a crazy math question, you know, like 3 horses is equal to 30, and a horse and a horseshoe is equal to 18. What is a horse, a horseshoe, and 1 horseshoe equal to? And I'll put that up, and he'll say 4, just like yours is 0.
Yeah.
All right, that's enough for today. I've went over 3 sections, which y'all won't be able to do too. But I don't know. What is Monday? Hallelujah. Thank God. I'll just count everybody here. Y'all just go on. Have a good weekend. See y'all Wednesday. And y'all should be able to work on all this homework then, since you're not here.
I got an easy question that you can help me with.
No.